Continuing with Section 3, Chapter 8, Sampling Distribution of the Sample Mean. An example. Tortoise Industries has seven production employees. Consider the population. So notice this is a simple example. The population is 7 employees. The hourly earnings of each employee are given in the table below. Joe, Sam, Sue, Bob, Jen, Art, and Ted make 7, 7, 8, 8, 7, and 8, and 9 wages. Question 1, what is the population mean? Question 2, what is the population standard deviation? Well, the mean is just adding the values and divided by 7. That's 771. And the population standard deviation, sigma, is the square root of the variance. And please notice that on the numerator here, we need the summation before the x minus mu squared. So on the numerator here, what you have is 7, the first 7 here, minus 771 squared, and then plus 7 minus 71 squared, plus 8 minus 771 squared, etc., till you complete the 7 differences squared. Add them up, divided by n, the 7 again, that gives you the variance, and then the square root of that will be 0.70. So the variance should be 0.49. Now in Excel, I copied the values here, and you can calculate the average. Just type equal average, then in parentheses, open parentheses, between B3 and B9, B column B9, close parentheses, enter 771. And the standard deviation of the population, it'll be STDEV dot P, equal STDEV dot P, open parentheses, again, the range is specified, B3 column B9, close parentheses, click enter, and you get approximately 0.70. Now the next question is, what is the sample distribution of the sample mean for samples of size 2? So notice in this case, we can actually obtain all possible samples of a specific size. In this case will be 2. To arrive at the sample distribution of the sample mean, we need to select all possible samples of size 2 without replacement from the population. In other words, we take 2 and then another 2, another 2. We don't take 2 and then put them back into the population. Then compute the mean of each sample. And there are 21 possible samples. You use, to calculate the number of samples, you use the formula for combination. You should have learned this in Econ 34.2 in the combination chapter, or the chapter that discusses the binomial distribution. And I will review it quickly here. Combination, this is a combination of little n items coming from capital N items. So we have a total of 7, and little n is 2, the sample size. And the formula is capital N factorial divided by little n factorial times the difference between the two n's factorial. So that is 7 factorial divided by 2 factorial, and times the 7 minus 2 difference factorial. In other words, 5 factorial. And what is the concept of factorial? The factorial of 4, for example, is 4 times 3 times 2 times 1. So the factorial of 7 is 7 times 6 times 5, etc., until you reach 1. And so in other words, in 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2. I'm not going to multiply by 1 because it's the same. Divided by 2 times the factorial 5, which is 5 times 4 times 3 times 2. So if you notice all these 5, 4, 3, 2, they can be canceled out. That'll leave 7 times 6, 42 divided by 2. That is 21. Or you continue canceling things, divided by 2, that's 3, divided by 2, this one is 1, so 7 times 3 equals 21. So there is a 21 possible number of samples. Now if you combine, notice each employee, Joe is the first one with the following person, Sam, and then with the following, Joe and Sue, Joe and Bob, Joe and Jan, Joe and Art, Joe and Ted. You get, these are the two earnings for the two, 7 and 7, 7 and 8, 7 and 8, 7 and 7. And you can calculate, add them up, divided by 2 gives you 7. Here, 7 plus 8, 15 divided by 2, 750. And then you move to the next person, Sam, combined with Sue. Notice that you don't combine Sam with Joe again because the order in this case does not matter. So that's why you use a combination formula. And remember, the order doesn't matter. In other words, it doesn't matter whether it's Joe, comma Sam, or Sam, comma Joe. That's the same outcome. But you have to do the Sam and Sue, Sam and Bob, because this hasn't been they haven't been paired before. All right, so you continue doing this for all possible combinations of two people, and you should come up with 21. And calculate the mean for all of them. So these values should be values close to 7.71. Okay, so these are all the means possible coming from all samples of size 2. And if you read that table, you'll have an average of 7 3 times, an average of 750 9 times, an average of 8 6 times, an average of 850 3 times. And this is a total of 21. If you take the ratio of 3 to 21, 9 to 21, 6 to 21, 3 to 21, you'll get what is called relative frequency. Relative frequency is the same as probability. So if you select somebody randomly, what are the chances that this person will make? I'm sorry, if you select the sample of size 2 randomly, what are the chances that this average will be 7? Well, 14%. Why? Because 3 out of 21 are actually have an average of 7. And then you use the same concept for the other ones, okay? All right, so that is the probability distribution. If you notice, it'll be higher for 750, right? And the next one higher is 8.2857. So what you get is approximately a normal distribution with a low probability for 7, relatively low probability for 850, and higher for the middle value 750 and 8, which is expected. And if we look at the distribution of the population, we have 7 and 8 and 9 possible wages. 7 is repeated, I don't know how many times, but it's a 40 point something percent. 8 is repeated almost the same amount of time. I think it's the same amount of time. We can look at the chart. 7 is repeated 3 times, 8 is repeated 3 times, and 9 is repeated 1 time in the population. Okay, so you get a result like this. You can just select frequency here and insert a bar graph. Just selecting the frequency, and you can quickly see the distribution 3, 3, and 1 frequency. And then you can change these labels, but this is not relevant for our class. Just getting an idea how this looks like, that's what matters. It's exactly the same as this graph here on the left. And if you do the same for the distribution of the sample means, the table that we just saw right here, which is coming from this table, then the distribution, notice that follows more a normal distribution. Okay. Now, and the values are more closer to a specific value, and that specific value is the average 7.71. Okay, so the standard deviation of these values, called the standard error of the means, is lower. And you can actually see it by calculating the standard deviation of the means. Okay, that is using all of these values obtained, all of these means that are, the 21 means, is equal to the standard deviation of the population 0.70. And you take the square root of n, the sample size, and you get 0.49. 0.49 is much low, if you notice, lower than 0.70. 0.7 is the standard deviation of the population. 0.49 is the standard deviation of the sample means. Okay, so the distribution of sample means is narrower around the mean. These observations can be made, or we can conclude the following. The mean of the distribution of the sample mean, 7.71, is equal to the mean of the population. If you calculate the sample mean of all the sample, okay, if you calculate the average of the sample means, or the average of the averages, well, add them up, divided by 21, based on the previous table, add all of this, divided by 21, and you get also 7.71. So if you can get all possible sample means for a specific size, in this case 2, then you can get a mean. The mean of this means, of these averages, is exactly equal to the mean of the population. All right, so that is conclusion number 1. Conclusion 2, the spread in the distribution of the sample mean is less than the spread in the population values, as measured by the standard deviation. As size of the sample is increased, the spread of the distribution of the sample mean becomes smaller. And if the n in the formula that is used to calculate the standard deviation of the sample means, if this n increases from 2 to 3 or 4, then this number, the 0.49, becomes smaller. The shape of the sample distribution of the sample mean and the shape of the frequency distribution of the population values are different. The distribution of the sample mean tends to approximate the normal probability distribution. And we'll continue with the next section next time.